Now let us begin the terminologies used in the trees. What is root? It is nothing but if a tree is not empty, the first node called as a root node. And we can concentrate on some basic terms used in tree data structure. Let us consider the tree structure which is shown in blue. Here you can see this is a first node, therefore it is a root node. This is called as a root node of 2 and 3. If I take 2 and 3, this is the root node. 2 is the root node for 4, 5 and 6, and 3 is the root node for 7 and 8, and 5 is the root node for 9 and 10, and for 11 7 is the root node. This is called as a parent node. These which one is 5, 2, 7, 3 and 1. This root node is also called as an ancestor node for 9 and 10 and 11. Now let us consider here the examples. What is here? I am taking a binary tree with all terms. First you can see 100, 50, 60, 70, 80, 40, 35 and 30. This is I have taken randomly with the values, and you can see how many height are there in here. You can see 0, 1, 2, 3. That is maximum height and depth of the tree is 3, and maximum level of the tree is also in a 3. Let us one by one. What is root node? Previously I have told that the root node is the topmost node in the tree hierarchy. In other words, the root nodes is the one that does not have any parent. In the above structure, node number 1 is the root node of the tree. If a node is directly linked to the some other node, it could be called as a parent or children relationship. For example, here you can take the example. This is only one node. Therefore, this 100 is called as a root node of this tree. What is child node? If the node has a descendants of any node, then the node is known as a children node. Here you can see 50 and 60 are the children of the 100, and 70 is the what? What is 70? 70 is the child of 50, and 80 and 40 are the children of the 60, and 35 and 30 are the children of the 80. Then what is the parent node? If the node contains any subnode, then that node is said to be the parent of the subnode. Here you can see 50, 60, 80. These are the subnodes. Therefore, this is called as a parent node. Here you can see 70, here 35 and 40 are the leaf nodes of this one. Which are the parents node? Parents node are 50 and 60, and this 70, 35, 30 and 40 are the leaf nodes. Then what is sibling? The nodes that have same parent are known as sibling. Which are the parent? 50 and 60. Here you can see for this the parent is 100. Therefore 50 and 60 are the siblings of 100. And here you can see 80 and 40 are the siblings of the 60. Next 35 and 30 are the siblings of 80. Siblings means what? It should have at least 2 nodes. See here you can, for 50 there is only one left node. Here it does not have any right node. Therefore we won't call this one as a sibling. Then what is leaf node? The leaf and the node of the tree which does not have any child node, then it is called as a leaf node. A leaf node is the bottommost node of the tree. That means here you can observe 70, 35, 30 and 40. Here it does not have any leaf node or any further generation or any further nodes. Therefore, this is called as a leaf node. Here you can see 70, 35, 30 and 40 are the leaf nodes of this tree, binary tree. Then we can tell what is ancestor. As usual, we will tell ancestors are nothing but grandparents. Similarly, here an ancestor of a node is any predecessor node of a path from the root node to the that node. The root node does not have any ancestors. Here you can see 100 is the ancestor of 50 and 60. Here you can see 60 is the ancestor of 100 and 50 and 100, 50 and 100 are ancestors of 70, 60. Here you can see 60 and 100 are the ancestors of 80 and 40 and 80, 80, 40, sorry, 80, 60 and 100 are the ancestors of the, here you can see 30 and 35. What is descendants? The immediate successor of the given node is as a descender of a node. That means here you can see the 100 are the descender of 100 and 50 are the descender of 50 and so on. Here there are two types. One is internal and external descenders. What are the internal nodes? The nodes except leaf nodes are called as tree nodes. That is, here you can see 100, 50, 60 and 80. These are called as internal node. Then what are the external nodes? Here you can see which are the outside. What are those nodes? 70, 35, 30 and 40. This is called as an external node and this part is called as an internal node. See, here you can see the descendants. I have said there are two types of descendants. One is left descendants and another one is right descendants. The nodes lies towards the left subtree of node X is called as a left descendants. Here you can see 50 and 70 are left descendants of 100 and here you can see 80, 35 and 30 are the left descendants of 60 and here you can see 35 and 80 are the left descendant of the 60. Similarly, here you can see the right descendant. That means a node that lies towards the right subtree node of the X are called as right descendants. What are here? This is the right part. See here you can see what is there 60, 80, 40, 35 and 30. This is lies in the right part of the 100. Therefore, all these are the right descendants of the 100 and here you can see this is 30 only lies for 80. Therefore, this is 30 is the right descendant of the 80 and for similarly 60 here you can see it is only 40 is there. Therefore, 40 is called as an what? Right descendant of the 60. That means a node that will is a part of the right side is called as a right descendant. Any node that is a part of the left is called as a left descendant. That should attach to the root nodes. Then what are the properties of the data structure of the trees? Recursive data structure. Tree is also known as recursive data structure and a tree can be defined as recursive because the distinguished node in a tree data structure is known as a root node. Then next, root node of the tree contains a link of almost the root of its subtree. Then the left subtree is shown in the yellow color in the below figure. Next upcoming slide I am showing, and the right subtree is shown in the red color. Previously also I have showed which is left subtree and which is right subtree with the numbers I have explained. Here I am taking with the colors. The left subtree can be further split into a subtree shown in three different colors. Recursions means reducing something in a self-similar manner. So, this recursive property of a tree data structure is implemented in various applications. Here you can see this is right and this is left subtrees. I think you can. This is the root node, and these 2 and 3 are called as a parent node. 5 is also a parent node, and this 5 is parent node for 9 and 10, and 2 is a parent node for 4, 5 and 6. 3 is a parent node for 7 and 8, and 1 is a parent node for 2 and 3, but 1 is an ancestor for all these nodes. Then now we can see how many number of edges are there. Then depth of the tree, what is the meaning of depth, that means how it is come, and the height of the tree. Here you can see the height diagrammatically I have shown from root node to the last leaf node we have marked. This is called as an depth, and this is an height. Here height is 0, 1, 2 and 3. That means totally 4 levels are there, and the height of this tree is 3 and level is also a 3. We have begin from the root node to the last node of the tree. Now let us go in terminology. What is that means? Number of edges. What is the number of edges? If there are n nodes, here you can see the then there could be n minus 1 edges. Yes, see here you can see how many are there, and each arrow in the structure represent the link or path. This one, each node except the root node will have the at least one incoming link known as edges. These are edges, and there could be a one link for the parent child relation. Then what is the depth of the node? The depth of the node x can be defined as the length of the path from root to the node of x. That means x means we will take this one as a last node. One edge contributes 1 unit of length in the path. So the depth of the node x can also be defined as the number of edges between the root nodes and the node of x. The root node has 0 depth. This is 0 depth, 1 depth, 2 depth and 3 depths. Then what is the height? The height of the node x can be defined as the longest path from the node x to the where leaf node. This you can see. Based on the properties of the tree data structure, trees are classified in various categories. I think you have understood what is level, height, depth and terminologies. Thank you.